Oh, I'm not the host anymore. Nevin, are you recording?
Yeah, I just started recording.
Okay,
did you give away your hosting privileges?
Apparently I did give away my hosting privileges, but I think it's okay as long as one of us is recording.
Okay.
Okay. So welcome, everyone, to the D'Anoia Institute of Philosophy's second annual seminar in Logic and Language, which is going to be given this year by Paul Egre. So the Australian Catholic University established the D'Anoia Institute of Philosophy in April 2019 to build a world-leading research center in analytic philosophy. Our name comes from the Greek word dianoia, which means thought, and is used by Plato in the Republic to denote the reflective and discursive reasoning that leads from mere opinion, or doxa, to knowledge or understanding, or nous. In 2021, we launched our online seminar series in philosophy, showcasing research by leading philosophers from around the world. A few notes before we start the seminar. Firstly, this event is being recorded, and after the seminar, we're going to upload it to our website. So Professor Egre's talk is going to go for about 45 minutes, and then we're going to leave about an hour for Q&A afterwards. So after the talk, if you have a question that you'd like to ask, please message me directly, and I'll add you to the queue. Finally, it's our custom at Australian Catholic University to give an acknowledgement of country. We commence our meeting by acknowledging the First Peoples and the traditional custodians of the country where D'Anoia is located, the Wurundjeri peoples from the Kulin Nation. We respectfully acknowledge their elders past and present, and remember that they have passed on their wisdom to us in various ways. Let us hold this in trust as we work together and serve our communities. And now let me introduce our speaker. So Professor Egre is a research director at the French National Center for Scientific Research, based at the Jean Nicod Institute. I apologize for my pronunciation of that. He's editor-in-chief of the Review of Philosophy and Psychology, and his work focuses on logic, the philosophy of language, epistemology, and cognitive science. His recent work has been exploring the logical, psychological, and semantic aspects of vagueness, and today he's going to be talking to us about the optimality of vagueness. So please join me in giving him a warm, albeit virtual, welcome. Over to you, Paul.
Thank you so much, Dimitri, for such a nice introduction. I'd like to say first that I'm very honored to be your guest speaker today, and it's wonderful to have this opportunity to connect also to Melbourne, where I was never, I was never in person. So, and it's probably my first also contact online to give a presentation on your continent. So it's really wonderful. Thank you very much for this invitation. My talk has a title on the optimality of vagueness, and then it has a subtitle around, between, and the Gricean maxims. I'm going to explain this. This is joint work with three co-authors whom you see here: Benjamin Spector, who's one of my colleagues at Institut Jean Nicod; Adele Mortier, who used to be our master's student, now doing a PhD in linguistics at MIT; and Steven Verheyen, who's a professor of psychology in Rotterdam in the Netherlands. This project started nearly like 5 years ago, when initially with Steven Verheyen, and then we joined forces with Benjamin Spector and Adele Mortier on aspects I will shortly explain, but you will see, I should say, a version of this paper can be found on the archive repository, and you'll see it has a very some parts are very technical. Some of these very technical parts have been very meticulously worked out by Benjamin Spector, especially parts I won't talk about today in the interest of time, but I wanted to highlight this point. Now, what is the topic I want to talk about? As you may know, so vagueness is characterized notably by Russell as a one-many relationship between an expression and its meaning. So it's a phenomenon very much related to structural ambiguity. And in scientific language, it's viewed as a deficiency, it's eliminated. In ordinary language, however, it appears to serve some useful epistemic and communicative purposes. So the general question this paper is trying to address is why language is vague. There's a famous unpublished paper by economist Bart Lippmann on this. What the utility of vagueness is, earlier work by Rohit Parikh also on this. And the general perspective is basically to model communicative exchanges involving vague or precise sentences. So the question is, what is the function of vagueness in language? Now, vagueness could be seen as a deficiency, but it's also a resource. And in a slightly underappreciated line of thinking in the literature, there's this interesting connection between vagueness, uncertainty, and prudence in communication. So I think Russell was the first to highlight that a vague belief has a much better chance of being true than a precise one. And Jonah Channel made the point a little differently, saying that vagueness may be used as a safeguard against being later shown to be wrong. And you find this idea over and over in the writings of different people like Krivka or von Demter. So Krivka refers to philosopher Pierre Duhem, speaking of a balance between precision and certainty. And so it might be prudent to be imprecise. And same idea in the next quote. Now, all of these authors emphasize a link between vagueness and error minimization. And so one may think that the primary, let's say, function of vagueness is to secure the maxim, the Gricean maxim of quality, namely that you should say what you believe is true, but also make sure that you have the right evidence for what you're saying. However, there's no distinction in these writings between using vague expressions as opposed to using precise expressions, but which might be logically very weak. So, namely compatible with many possibilities. If you wish, with a disjunctive, let's say, structure, and I'll give example of that distinction. So now, precisely because Gricean quality cannot be the main, let's say, or the only reason for why we use vague language, the idea is actually to suggest that vague language can be optimal in situations in which the speaker is imperfectly informed about the world, relative to any more precise way of communicating information. In other words, the idea is really to make vagueness a way of optimizing a trade-off between Gricean quality and Gricean quantity. So the idea is as much information as necessary for the purpose of communication should be conveyed in the face of uncertainty. To put it differently, the idea is to say that semantic vagueness, if we define it as the underspecification of a semantic parameter in some expressions, I'll be more articulate about that, can be pragmatically recruited to communicate a probability distribution. And this is best shown using a Bayesian model of interpretation. Now, in fact, the part of the talk that I won't develop is this embedding of this idea in the influential by now framework of the Rational Speech Act model of communication. Something along these lines was done by Dan Lasseter and Noah Goodman in their account of Bayesian communication involving gradable adjectives. We're doing something similar, but which started in a different set of hypotheses. So let me first say something about the distinction between vagueness and precision, and say why it might be better to be vague rather than precise. So there's a host of reasons what one might use vague language. There are cases where the speaker is non-cooperative. The speaker holds precise information, but the speaker deliberately uses vague language, so less precise language, to hide precise information. So with Benjamin Spector, who's a postdoc with me, now we studied cases of this kind, connecting, let's say, deception and vagueness. So ways in which one might want to omit information. I won't dwell on these cases, but I'm happy to go back to them in the discussion, because I'm primarily interested in cases in which the speaker is a cooperative speaker, holds precise quantitative information, but where precision might be less informative than using vague qualitative language. And cases like these have been proposed by Frank Veltman. So for instance, reporting absolute magnitudes can be much less efficient than reporting, let's say, relative magnitudes phrased in qualitative language. But these are cases in which, let's say, the speaker is fully informed. So the primary focus in the paper is actually cases of a third kind, where the speaker is cooperative, as in the second kind of scenario, but actually lacks precise quantitative information. I think cases of that kind are much more prevalent in everyday life. And so I'm going to focus on the third kind of cases. And such cases, I should say, have been also were discussed initially by Williamson, for instance, in his classic book on vagueness. We'll see an example in a minute. Well, there it is, actually. So consider a situation in which an agent attended a party, but could not keep track of the precise number of attendees at the party. So it could be like watching a crowd, and the question is how many people were there at the party, or how many people do you see if you're at a party. And in practice, although this is not the way actually Williamson, for instance, accounts for the case, but in practice, the speaker does not know the exact number of people in the crowd. So the speaker has a probability distribution on possible values. And let us suppose the support of this distribution, so the range of non-zero values of possible values to the speaker is 40 to 100. But I'm going to assume that the 80% credible interval is confined to the range 60-80. So, and this means you get something like the shape. Let's assume that the shape of the distribution is what you see on the plot here, where 80% of the mass of this distribution is between 60 people and 80 people. That's the red part. Now, in response to the question, how many people were there at the party? Let's examine the options. So if the speaker wanted to be as precise as possible, the best, let's say the most precise answer that can be given is exactly n people for some number n. But by saying so, the speaker would necessarily violate quality for every number, either because the answer would be false or because the answer would be true but unjustified, just true by luck. The next move is to use this what I called a logically weak expression. So an expression with highly disjunctive meaning, like between 40 and 100. So in this case, this actually corresponds to just communicating the support of the speaker's distribution. And notice that the maximum of quality would be satisfied here, because the speaker says something that they believe is true and that is justified. But there's an interesting sense in which the speaker fails to inform the listener about the shape of the distribution. Meaning that if you just communicate the support of your probability distribution, you leave so many options, so many possibilities about the shape of this distribution underspecified. So this is going to be a central idea in the rest of the talk, that the shape of the probability distribution is something we want to communicate. You could say, well, there's a third way of going about, which is actually to select an interval which is more narrow, closer to the speaker's experience, closer to the, let's say, the peak of that distribution. But if you say between 60 and 80, if you remember the shape of that distribution, there are values outside that range. And so this would be a possible violation of quality. Last, the speaker could say, I'm 80% confident that between 60 and 80 people attend the party. So note that it's actually harder to express. I mean, it's certainly more costly. There are issues also as to, whether this confidence level could be certain in practice, but we could assume that. But basically, the leading idea in the rest of the talk is there are expressions in language, these approximation expressions like around, such that if the speaker says around 70 people were at the party, the speaker more directly communicates his or her or their epistemic state. So notice that the expression around does not refer to any explicit dimension of confidence or probability. But notice also that it's vague in ways that, the other expressions here are not vague, and I'm going to explain this. So let me move on to the explanation of this point. As you could see in my examples, setting aside the case in which people report explicit levels of confidence, just dwelling or focusing on the opposition between using around and using between, when we say around 70, let's say, this expression appears to be vague in the sense in which it's compatible with an open-ended range of values, whereas between specifies a sharp interval. So if you hear there will be between 60 and 80 people, of course, every precise expression, or nearly every precise expression, I should say, can be used with slack. But if you just look at the truth conditions, if you say there will be between 60 and 80 people, or that's the answer to how many people will there be, it's strange to say, well, so possibly there will be, to infer from this, there will be 87 people, just to infer some number of outside the range, unless you think the speaker has a specific bias on reporting magnitudes, but if you think the speaker is knowledgeable and has no bias, that should not be an inference to make. On the other hand, if you hear there will be around 70 persons, it's fine to infer, so possibly there will be 87 persons. In fact, it's unclear what values are ruled out by using around 70. So that's the first observation. The second one has to do with the connection between around and Sorites susceptibility. So the idea is that around is Sorites susceptible in a way that between isn't. So if n is around 30, arguably, so is n minus 1. At least that's not an obviously bad inference. On the other hand, if n is between 20 and 40, n minus 1 may very well not be. So look at this, right? 20 is around 30, so is 19. But 19 is not between 20 and 40, even as 20 is between 20 and 40. The third observation is It's a bit more subtle. It is the idea that assume that you have no particular idea or expectation about how many people might turn out or turned out at the party. Then hearing around 70 appears to convey that the values closer to 70 are more likely in the speaker's mind than more remote values. Whereas if you hear between 60 and 80, it does not obviously make any value in the interval more likely than the others, assuming again that you start, from no particular expectation, that you think every, possible value is initially equally likely as the others. And this intuition, it's called observation here, but maybe it's more prudent to call it an intuition. We call it peakedness, and the idea being that values closer to the target number are more likely. Now, yeah, okay. I said it, so I won't lose more time about this. Now let's look at ways in which the meaning of expressions of a vague expression like around has been explained. So, for instance, Krivka, Manfred Krivka, Stephanie Zold have proposed that when you say around 70 or around 10, let's say, what the expression means is actually some fixed interval, symmetric, centered on 10, and it can be expressed as n minus u over 2 to n plus u over 2, where u is a textually given granularity for the scale. So if you set u to be 2, right? So around 10 would be the interval 9 to 11. If you set it to be 10, it would be 5 to 15, and so on and so forth, right? So if you set it to 1, it would be 9.5 to 10.5, and you can sort of you can make it more and more fine-grained. But the problem with this proposal is that vagueness is arguably left out, and the other two observations I was mentioning are also seem not to be accounted for. So by saying there were around 20 people, assuming that that 10 is the granularity which is salient in the context, it should really mean the same thing as there were between 15 and 25 people. But intuitively, the first sentence is not clearly false if there were 26 people. So of course you could say, well, is there a clear distinction here between, maybe around is again an expression which is like between, and we can use it with slack. But this is not the theory I'm going to go for. So basically, I want to capture precisely the difference between 9 and 10, right? Like saying there were around 70 people, and all these various options which correspond to the various meanings that fall out of Zold's or Krivka's theory. So here is a different proposal, and that's the one we're making. The idea, just look at the part behind the string of lambdas here. X is around n, means that x belongs to an interval of the form n minus y, n plus y. And the difference between what we had before is now y is this open parameter. So it's a free variable, and we have to actually resolve the underspecification of that variable when we hear around. So that's what is crucial to the sort of argument here. The idea is, let's model the listener of a sentence like there were around 70 people by a probability distribution. So what is actually a little subtle is that the listener should make inferences both when hearing around 70, both about the number of people present at the party, but also about this open parameter. So about the value that, let's say, about the range which is likely to be operated by the speaker when using around. So the first thing is this probability that x equals k. So x is the number of people at the party. That's the random variable representing that number. And this probability represents the prior probability of the listener that this random variable takes on a specific value. Okay, so that it's really a probability on the world, if you wish. It's about the size of the crowd, right? About the size of the group of people. But then there's this probability distribution about y. Y, remember, is this parameter in the meaning of around. And the probability that y equals I represents this time a probability on meaning. It's the prior probability that the interval picked by around has a specific radius. Okay, and we can assume that these prior probabilities are independent. So in general, I'm going to assume that the joint probability is just the product of these two probabilities, okay? Now, the listener's problem is to figure out the conditional probability distribution defined by this equation. So what is actually the number of people at the party? And what is the probability of this number being k, hearing that the number in question is around 70, let's say, okay? So now we can represent this in terms of our truth conditions for around. And what we can derive using Bayes' rule actually is that the closer a value is to the target number 70, the more likely it is to be in an interval of the form n minus y, n plus y, right? And this can be, let's say, felt true. This can be also made more rigorous. Basically, if you want to derive this posterior probability, so the probability of x being equal to k when x is around n is this sum of the joint probability that x equals k and y equals I over the possible values I that y may take on, right? So now from this equation, by Bayes' theorem, you can show that the probability of the number of people at the party being k, hearing x is around n, is proportional to your prior on the number of people at the party, weighted by the sum of the various probabilities given to the intervals that around specifies, or to the radii, if you want, that this expression means. So a picture will actually help explain what is going on here. So assume that, initially you have a uniform prior on the number of people coming to the party. And you think, well, it could be 0 to 40 people. So apologies for changing the numbers always, but it's actually easier to plot this and make it visible. So this red line here represents your uniform prior. Now assume you have a uniform prior also on the possible intervals denoted by around 20 in this case. And you hear around 20 in response to how many people were at the party. Now what happens is the shape of your posterior distribution is the one represented in black here. And it has exactly the features which I was mentioning. You can see that it's peaked on and centered on 20. And you can see that it gradually tails off to the extreme values. And you can see that it's non-uniform, so compared to the uniform prior. On the other hand, if you heard between 10 and 30 people, the blue line just represents your posterior, and your posterior is a uniform distribution in this case, right? You just kill off the values outside the range. So in the one case, from two uniform priors, you get a non-uniform posterior, unlike in the use of between. And so, as you see, this little toy model captures the three observations I was making about arounds, so that the truth conditions of around are vague. Why vague? Well, in the sense that they have this open parameter in the expression of their of those truth conditions. Then there is something like Sorites susceptibility, because the posterior for x being equal to k is very close to the posterior for x being equal to k plus 1, which is exactly this intuition that there's a connection between vagueness and closeness, the way Nick Smith, for instance, put it. And there's this peakedness phenomenon. The posterior, as I said, on around is peaked, unlike what it is for between. Now you could say, well, it's all nice, but what about, a case in which you start from non-uniform priors on the number of people at the party? And in this case, we can derive something like peakedness, but it has to be in the form of a ratio inequality. And what 5 basically expresses is that if you take two numbers, k1 and k2, such that k2 is larger than k1, when you compare the ratio of the posterior values, so what is the probability of x being equal to n minus k1 compared to the probability of x being equal to n minus k2? So intuitively, k1 is closer to the number n than k2 is. And you can show that this ratio is actually larger than the ratio of the priors. However, this ratio of the priors is also equal to the ratio of the posteriors that you derive for the corresponding between statements. It means that even if you started from a very, let's say, U-shaped prior, this U-shaped prior would be slightly sort of bumped up into a new posterior compared to what you would get using between. So it does really affect the shape of the posterior. Okay, so now I want to, having said this, and I'm using a lot of my time to present this model, but I want to give you this sort of positive philosophical argument for what I call the optimality of vagueness. And I'm going to try to press on, but I think it's important to have the details in mind. Assume the speaker now makes an observation, and the question is, so far we were modeling the listener, but what about the speaker? So why would a speaker want to use around? In fact, if the speaker has a private distribution with support between 10 and 20, let's say, and this distribution is biased towards central values, the idea is that it might be more informative to say around 15 than saying between 10 and 20, even if the around 15 sentence does not categorically rule out values outside the support. And the way I want to show this is as follows. We need to find a notion of being informative such that, using around 15 in this case, results in a posterior distribution in the listener's mind, which is closer to the distribution of the speaker. For instance, because it would give high probabilities to central values. So for that, we need a notion of being informative, which is just more fine-grained than a qualitative notion just based on entailment. And that's why I hope I can explain here. So first, a remark, which is that every possible choice of an interval length for an around statement makes it equivalent to a certain between statement. This falls out of the truth conditions given for around. So there's no way the sentence is going to be both true and more informative than every between statement. So what can we do here? What we can do is just observe that even if whatever the support of the listener's distribution after hearing the wrong statement, there's a between statement that expresses this support. Again, it could be that some values which are not killed off by the around statement make the posterior state of the listener closer to that of the speaker. So the notion of informativity we need here can be represented as follows. So you view the speaker as aiming to bring the listener's distribution close to that of the of themselves. We need a measure of closeness between probability distributions. So let's assume listener and speaker have the same distribution initially over the values of interest. Now the speaker makes a private observation. It results in a new probability distribution in the speaker. The listener made no relevant observation, and this is common knowledge. Then the speaker chooses a message, and the choice of that message is governed by the desire to make the listener's distribution as close as possible to her distribution. Okay, so what we need is this prior distribution, P, a speaker distribution after an observation, we're going to call it PO, and a listener distribution after processing a message M. Let's call it PM. And well, now maybe I shouldn't use all of my time for this, but basically, let me say this. There's a way of which I could explain with more time, of measuring the distance or divergence between speaker's distribution and listener's distribution. It can be information theoretically derived based on this notion of surprisal. So when learning that x equals k, the speaker could be surprised, and the surprise is a function of the prior probability that x equals k, and we can represent it by minus log, right, as is done in information theory. The listener has the same surprisal relative to the message this time, and the goal of the speaker is to minimize the difference in surprisal between them. Now, how should they do? Well, given that the speaker is uncertain about the value of x, the best you can do is to minimize the average difference between the listener's future surprisal and the speaker's future surprisal. Now, if you do this difference between surprisals, you get the difference between these two logs of the probabilities of the speaker and of the listener. And now the expectation of this difference from the point of view of the speaker is just this weighted sum of the differences between the surprisals weighted by the prior probability that the speaker gives to x equals k. Now, if you rewrite all this, and it's very tedious, I apologize, but you end up with what is known as this Kullback-Leibler divergence. This is exactly what I try to justify. And so the strategy of the speaker is to choose a message which minimizes this difference. Okay. Now, I'm going to give this example, and I think I will have just a couple of minutes to sort of extract a philosophical lesson from this. Now, look at the example, because it really is an existence proof of optimality for vagueness. So assume the speaker and listener start out from this prior distribution on the number of people at the party. Now it's a small party, right? So the number is any number between 0 and 8. And you have this uniform distribution over these 9 values. Okay, same between speaker and listener. Now, after observing O, and I apologize because we use the same expression here. So now PO means the speaker's distribution after an observation. The speaker deems 4 to be the more likely value, right, compared to the others. So you have this peak distribution. And the speaker has the choice between using an expression like between 1 and 7, which would basically express only the support of the distribution and respect the maximum of quality, or using around 4. And around 4 actually rules out no values, as you could see from my previous graph. So it actually does not exclude 0 or 8, but it's a peak distribution. And the listener's posterior distribution after hearing between 1 and 7 is just this uniform posterior. You just put 0 on 0 on 0 and 8. When hearing around, as you see, so some values here, the extreme values have non-zero but negligible probability, and 4 actually has most of the probability. And if you calculate this Kullback-Leibler divergence between the speaker distribution and the listener distribution in the two cases, you see that it's larger in the between case than in the around case. So the speaker prefers around. And as you could see, using any more precise interval would also sort of just increase the divergence in this case and be suboptimal. Of course, this could be embedded in a larger model of interpretation. And since I'm almost at the end of my time, I won't go into the details, but basically say that, my colleague Benjamin Spector basically did a lot of work to extend this model into a fully interactive model of speaker and listener making inferences about each other in successive levels. I want to finish with a philosophical lesson which concerns this debate between Crispin Wright and Timothy Williamson about the nature of vagueness. Well, as is well known, Timothy Williamson endorses an epistemic conception of vagueness as ignorance. Wright, in a 1995 paper titled The Epistemic Conception of Vagueness, expresses skepticism about this. And there is an interesting passage in this paper where Wright focuses on approximators, so expressions like around, roughly. And he notes that the role of such particles seems unquestionably to be to introduce some conveniently indeterminate degree of flexibility. And then he goes on to say, well, if I claim Jones is roughly 6 feet tall, the epistemicist must so construe the truth conditions of what I say that for some fixed k and j, they coincide with that of the statement, Jones is more than 5k and less than 6j. So it's basically, Jones is between this value and that value understood precisely. In fact, Wright does not give a conclusive argument against epistemicism, if such might exist. But basically the construal of his view is as follows, right? Around 6 feet tall does not mean, or this is what I want to propose, it does not mean between 6 minus u and 6 plus u for any fixed u. There's no argument of irreducibility in his paper. But as I showed in the examples I gave you, every possible choice of interval length for an around statement is equivalent to a certain between statement if you precisify. But for every between statement that may be a surrogate of the around statement, the effect of uttering and using this between statement is different from the effect of using the around statement and could be suboptimal. So the upshot is that around does not mean this or that between precisification in the example. It really requires speaker and hearer to put probabilities on an open range of precisifications. And in that sense, you could view the argument as an argument for vagueness being primarily semantic as opposed to epistemic. Still, the present account starts from a semantic account of vagueness, because vagueness is seen as this presence of a contextual parameter in the meaning of some expressions. But it derives the utility of vagueness from epistemic considerations, because vagueness is not just a mechanism of error minimization, it's a mechanism of information transfer relative to uncertainty. And so I should conclude that the opposition between semantic and epistemic vagueness is inadequate, more generally, because we need both dimensions to rationalize vagueness. Okay, and I'll conclude by asking whether the account could be generalized. I think it can be generalized to more expressions than just approximators, but maybe we can talk about that. I'll just conclude that sometimes it is thought that for every vague expression, there's a precise one that is more informative. It's correct if you look at informational updates in terms of just the support of a distribution over possible states of the world. It's incorrect if you think the goal of communication is also to communicate the relative probability of worlds. And in that case, some context can make a vague expression more informative than every more precise alternative. And I finished. Thank you very much for your attention.
Thanks so much. I think we're now going to take a break, which is going to be around 5 minutes, and then come back for Q&A.
All right.
Now, if that's okay. Okay, so just to remind everyone, if you have a question that you'd like to ask during the Q&A, just send me a direct message in the chat. But let's get started with a question from Sam Carter.
Cool, thanks a lot. I really enjoyed this. So I'm right in thinking, right, that the reasoning that Egre is doing in updating is entirely based on the probability distribution over the semantic value of the utterance, right? They're not doing any sort of second order reasoning about what message the speaker is going to choose based on what they think, how they think the hero will respond. Is that right?
Right. So in the version of the model I gave, there was no further inference about, let's say, why the speaker may, or let's say the speaker inferring that the listener may infer that they themselves use the around sentence as opposed to the between sentence. And that part is actually the interactive model, which can be implemented in this rational speech act framework. So Benjamin did the implementation of that model, and hopefully, yeah, that can address your question. I should let you finish the question.
Yes. So I was interested sort of in how that goes in the way that you generalize it. Because I was thinking one thing you might think is, okay, well, that's just going to kind of amplify the effect of this peakedness thing, right? Because the hero will be able to infer that the speaker is trying to get them to adopt a kind of peaked Gricean function like this. Then I was thinking, well, if you also allow other sorts of preference, there might be other sorts of preferences that you want to allow the speaker to be sensitive to, which might actually disrupt the peakedness effect you have. So there's this thing that kind of Krifke talks about a bit, which is like this preference for using sort of really salient or round numbers. So like you prefer to use like 10 than you do, say, like 13. And you might think that like also holds even when they're embedded into things like around. I think if you have that, it's not so obvious to me that if you include the second order of reasoning, you'll retain at least the strict kind of peaked effects, because if the hero is very confident that the speaker has a very strong preference for using these round numbers, right, then they'd expect them to use around 10, even if their Gricean function is centered on, say, 11, right, and has a normal distribution with the peak at 11. So I was thinking, what if I'd be interested to hear more about those models and whether you get a strengthening of this effect or whether you actually can deviate away from this peak update.
Thanks. Yeah, excellent question. So definitely the extension, the generalization of the model predicts an amplification of the effect, of the peakedness effect that I was mentioning. But as you say, the current model ignores other aspects of using around, especially precisely what you described. So the difference between round numbers and non-round numbers is ignored. In fact, so there is a way of extending the model, which actually Adele has explored in her master's thesis. There's a way of differentiating round numbers from non-round numbers. That actually involves introducing, I mean, these are rational speech act models involve using a notion of cost, which I haven't talked about because I haven't presented the rational speech act model. But basically, cost could play a role at different spots in this account. One would be that using round numbers is less costly than using non-round numbers. And the other could also be that using a round might be also less costly than let's say using between intervals, if you think that in the one case you specify just one numerical value, in the other you specify two. And as you say, I think this, for instance, the latter difference is going to act as a countervailing force on the account, because then if the effect is still going to be present, but it's going to be weakened by the fact that just using a round would be less costly to begin with. And that's one thing. The second thing is, if you assume the costs now to be constant for a round and between expressions, then the difference will hinge only on whether the target number after a round is a round number or not, let's say multiple of 10. And there's definitely the interaction you mentioned. So the kind of effect that Krivka reports, and that was also something Zolt drew my attention to, is you could also say around 20 if you know the actual number, to be 19, let's say. But note that you wouldn't say around 18 in the same context, right? If you know it's 19. So there's the sense in which peakedness has to stay underlyingly present, but it needs to interact with round numbers, meaning that then the next, sort of the closest round number to what you said is again a value which on which the probability distribution should be peaked overall, even if the speaker actually has a probability distribution whose peak is actually slightly shifted from the actual round number used. So yeah, that's. I hope that answers your question. But that's these are two refinements of the model. Yeah.
Can I have a quick follow-up? Or?
Yes.
I think you can. I think there's enough time.
You have to ask Dimitri, yeah, of course.
So just it's a kind of comprehension check. Does that mean that if my preference for using around 20 is sufficiently greater than my preference for using 19 as a speaker, then I could actually get, say, you'd have you could in effect get a dip around 20, right? Because if it was guaranteed that if I thought it was certain to be 19, I would use around 20. But of course, if I thought it was certain to be 20, I'd use 20 rather than around 20. Then you're going to have a discounting for the likelihood of the speaker thinking it's 20, conditional on their using around 20, which you won't have for their thinking it's 19. So, and obviously it's going to depend on how likely I think you are to be certain of the number versus having, something like a normal distribution. But it seems like one effect you could get is that around 20 might actually get me to lower my credence in 20, but still have beaconess around the dispreferred, more costly numbers. Is that right?
You mean that it would lower the listeners?
Yeah, the listeners.
Yes. I think that's, well, I'm unsure, to be honest. So this is where I think it's hard to sort of introspect to tell you what the result would be without going into calculations in this case. I suspect that it is possible, but yeah, I'm not able to actually give you a sort of a precise answer here. Yeah. But would that be a problem? So you think that
No,
would be sort of okay?
I was thinking that was interesting and potentially a nice prediction that sometimes when you say, Bob arrived like around 6 p.m., that can give me reason to think he didn't arrive on the dot, because you would have said he arrived at 6 p.m. on the dot if he had. I thought that was, if anything, a nice result.
Oh, thanks. Yeah. Thank you. Yeah, there's more to say about this. There's this paper also by van der Ernst and Sperber and Carlis that where they I think they observe effects like that, and reports of people telling the time, where people prefer to even with digital watches actually to not report the exact time, but just use the next round number, or just to round off. I think all these considerations involve this notion of cost, which I haven't indeed here introduced at all. But you're right. I think to give a full account of the phenomenon, especially of these approximators, we need to take that into account. Thanks.
The next question comes from Simon Goldstein.
Hello. Okay, my question's a little speculative, so sit back and relax. So I was kind of thinking like, I was just kind of thinking like how I think of the optimality question in the case of like tallness or something, and it's a little different. I was kind of wondering how to interact. So I was thinking like, if I see someone's height and then I'm supposed to tell, the hearer about the person, about this random person's height or something. It's like if I'm choosing between things like he's at least 5'6", he's at least 5'7", he's at least 5'8", things like that, or I guess 1.7 meters, 1.8 meters. It would be a very frustrating experience for me because all of those choices are very similar in the value to me of communicating them. So there's like no tiebreaker. You know what I mean? Whereas then if I just say they're tall, like, there's no alternatives that are equally good. So switching from the scale that's 5'7", 5'8", 5'9" to the scale that just has tall or not tall, it settles that, it removes that deliberative uncertainty to me. Also, if I said like 5'7" or something, I generate all these applicatures, because there's all these salient alternatives. And so I was thinking like, that's kind of a different approach to the optimality of vagueness. And in the case of like around and stuff, the analogous thought would be like, well, if I say between 60 and 80, I could have said between 55 and 85. And, there are all these different choices of endpoints that I could have done. And I also have to choose a middle. Whereas when I switch to around 70, I've settled one dimension, of the problem. I don't know. It just struck me that's like a very different way of approaching it. I was just kind of curious if you think that's like a crazy way to go, or is, I don't know.
Well, the thing is, maybe I'm too attached to the account I was offering. But it seems to me the competition is just going to be the same, right? So if you use you're right. So the difference between, let's say, the around case and the between case on the one hand, and the at least and tall on the other, is just that there's sort of, in the one case you specify two boundaries, right? And in the one case
Exactly.
you specify one.
Exactly.
But still, I think you have a host of, let's say you could still flout, right, the maximum of quality by trying to specify the closest at least bound, right? So you have the same predicament, right? Which is you don't want to exclude values with certainty, and you want to communicate what you think is a likely value relative to a threshold which is left underspecified. So that's the sense in which I think the example would remain very similar, and the rationalization of using toll would be also very similar. But it could be that I missed what your sort of distinctive take was on the
I think
toll
it's
example.
clearest in the example of tall. So it's like if you're choosing between saying he's 5'7" versus he's 5'8", that is like a totally arbitrary decision. There's no reason for or against it. But like rational speakers want to have a principle of sufficient reason for speech acts, where they're of the things they're choosing between, they pick the one that makes a lot of sense to say, and the other ones don't make sense to say. So if I'm choosing between 5'7" and 5'8", it's just going to be like crazy to pick between those. But that's why if I switch over to tall, that one has no competitors that are as good. That was the idea.
Yes, I see the idea now. I see it better.
There's a limit to how much idea there is to see.
No, but I still wonder if it's let's say substantially different, because I think what I hear is that you are wondering about indifference, about ties, and I wonder if this notion of a tie is actually not already covered by, let's say, the fact that even in the between case, you could also use two different between intervals which are very near each other. And if I say, well, then comes around actually does the job, it seems that the proper way of articulating this is also by just showing that tall is actually a better alternative than any of these alternatives between which I might be slightly indifferent, right? So I think the slight indifference thing is partly orthogonal to the first step, which is show that toll is actually better than any of these alternatives.
I see. Yeah. Interesting.
Okay.
Yeah. Okay. Cool.
Thanks for this.
The next question comes from Nevin Clemenhaga.
Thanks. So it was a very interesting talk, Paul. Thanks a lot for that. And I really like the model. It seems like it can do a lot of interesting work. I have two small comments. So the one is following up on Sam Carter's question, because I was wondering the same thing about like psychologically salient numbers. So I wondered with the notion of costs, which I think is a really interesting and plausible thing to add in here. I had a thought, maybe you've already thought of this or another way of doing it, but of how to measure what numbers are costlier to use. Because in your response to Sam, you just said like round numbers, which is a little big. But it seems like there are some numbers that are more salient than others. And so I wondered if maybe the Kolmogorov complexity of a number would be a useful measure here. So that's a measure that looks at the ideas like what's the shortest input to a Turing machine that would output this number. And so numbers like 100 are going to come out as having lower complexity than numbers like 99 because they can be factored in easily, or at least I don't know if that works for 99 and 100. At least when you get larger, like a million will be less. It will be simpler than a million minus one because they can easily be factored. And it seems this is an empirical claim, but it seems plausible to me that would track with how likely we are to use it. And I think I read in one paper that investigations of how often numbers appear on the internet tracks with Kolmogorov complexity. So that might be some empirical validation of this. I could try to find that reference if you're interested.
That would be great. Yes, I really appreciate the suggestion. I see I understand both what you're saying and also how it might help explaining when a number is around so-called round number. Yeah, I think that's very nice because indeed we do not even try to explain precisely the notion of a round number, and even in the writings. So I have a short version of this paper, by the way, in a festschrift that appeared in honor of Stephanie Zolt, where I say something which is not in any way a definition of round number, but more like, maybe a subset of the cases. Like if it's a multiple of 5 or 10, it doesn't explain anything. It's just a description. Whereas I think this idea of minimum description length is certainly more adequate. Yeah, that's great. Thanks. I hadn't thought about it.
Yeah, I'll find that reference and send it to you.
Thanks.
Yeah, the second thought was, again, just a minor comment, but in thinking about updating my probability distribution upon hearing somebody say there were between 40 and 100 people at the party, I don't think that I would assign equal probabilities to all of the numbers between 40 and 100. I think it seems right to me that I would not peak as much as if you told me there are around 70. But if you told me there were between 40 and 100 people at the party, I would think, well, what's the most likely way that you could have gotten that evidence? And I don't think that it's going to be that you looked at some, I don't know, like output of, like a computer told you, here are all the possible numbers of people at the party or something. No, probably you went in and you looked, and it looked like there were around 70, and you estimate that 40 is the lower bound, 100 is the upper bound. And so I would probably end up updating my probability distribution with a peak around 70 in that case too. But I don't know that this actually invalidates your model, what you do with your model, because it still seems to me like it would be less peaked than if you said around 70.
Thanks. That's a great question. I think the issue is really whether if you start out from this uniform prior on the possible number of people at the party, you could, using between, end up with a non-uniform posterior. And it's true that the model predicts that to be impossible, right? Because if you, given the truth conditions for between, you just get rid of some values, then you normalize, and you just move on from a uniform prior to a uniform posterior. So one response to your question, which I think is the one we've used so far, was only to say, well, if you have that intuition, it's because you probably did not have a uniform prior to begin with. So in other words, if your prior on X, the number of people at the party, was not uniform to begin with, then you could use between and still end up with something which is non-uniform. That's one option, and I think that's the sort of easy answer to the question. What I hear in your question is, could it even happen that there is a way of understanding between that does more work? Of course, I would say it doesn't, it doesn't result from the model. If that can happen, I wonder exactly how it would happen. It would have to be because we already, let's say, give between a slightly different meaning from just the sort of literal meaning I gave, which is this dimension of like using between maybe with some slack. And slack could mean not just slack on the boundaries, but slack also, or let's say enrich meaning on the what kind of distribution to expect when you hear between. That's interesting, actually. I have no sort of further thought about this, but I think it would be very hard to test, actually, if that to tease apart, let's say, between these two options. We would have to make sure that people have really, I think the best way is to think of future events, like for which you really have no idea. So if I tell you there will be, how many people should I expect tomorrow? And, or how many, yeah, maybe it's easier if you say, how many, well, but if I use can, maybe it sort of changes the rules. How many people can this room accommodate, let's say? And you say, well, between this number and that number. Well, of course, then we're sort of oriented toward looking at, all possible options. How many people can this room accommodate? If you say around 50 people, it means something else. I agree. It means something else. So there may be further interactions depending on, what objects we talk about, and also the kind of modal operator I use here. So that's a really interesting question. The best answer I can give is the first one, that your intuition is driven by having a non-uniform prior. But,
Can I briefly follow up, Dimitri?
Yeah.
Yeah, so just briefly, I think where my intuition is coming from is that when, in general, if you testify something, like you tell me that you know E, evidence E, then I wonder, how did you come to know E? And I update not only on, like, it's not just like I learn E, but I also learn that you know that E. And then I think about what's the most likely way for that to have come about. And, like if I tell you there's a tree outside my window right now, like I haven't told you I see the tree, but given your background knowledge, you'll think that that's the most likely way that I came to know that, not that I like learned of its existence in some other way. And so similarly here, if you tell me that there are between 40 and 100 people in the party, I'll think the most likely way you came to know that was by going and looking and making an estimate, rather than by like learning just in some other way where that would give an equal distribution over all of those numbers. So that was the intuition behind why I'm updating in the way that I am. And that's, I think, doesn't rely, I think that's compatible with my having an indifferent prior over the possible values. So it's a judgment about the probability of your testimony given the hypothesis, rather than a judgment about the prior probability of the hypothesis with the hypothesis being different numbers of people at the party.
all right. Yes, I see. That's interesting. I can say more, but I don't want to expatiate too much. Just to say that we've started also some tests. What Adele did in her master's thesis was also to try and test, whether the peakedness intuition was actually, confirmed experimentally. We found results which sort of seem to confirm, except that there are confounds which just led us to postpone, working on this and just first get the model right, theoretically. But yeah, that's interesting. Let's say what I hear is that you may not share actually the peakedness intuition, even in the case of the non-uniform prior case, and that's interesting because that's also a possibility. Yeah, that we're building on sort of too pure a possibility to actually account for what you're saying. Thanks.
Okay, so the next question comes from Samel Nolan de Guzman. Apologies if I mispronounced that. Their camera isn't working, so they asked me to read the question. And it is, it's whether you see how this can be applied to, I'm not going to be able to pronounce this, apophatism, which I'm sure I got that wrong, which I believe is the view that God is inconceivable.
And what is the technical word that Simil used?
I think it's apophaticism.
Thank you.
Can you type it in? Because I think it's my English here, not apophaticism. Thank you. I see. That's interesting. So is apophaticism having to do with the idea of ineffability, the idea that some notions might be ineffable? Okay, that's very interesting. So I think so. There are some really interesting, as you know, right? Probably comments by Wittgenstein in his philosophical investigations about vagueness and about the way in which when we try to precify, let's say we he suggests that we mean something different from what is meant by using a vague expression. This is around, all the passages, I think paragraph 70 and beyond in these philosophical investigations. So I think there's certainly a connection there because although I haven't actually written about this, I've thought to my amazement, just reading Wittgenstein, that his views about vague concepts being ineffable in a way could be also maybe explained in terms of this model that I'm proposing here, because the irreducibility part in the end connects with that thought. Maybe there's a slight distinction to make, right, between notions of ineffable or effable, which is that in the case of, let's say, a word like around, we know that we put in the truth conditions all its possible precisifications in terms of between sentences. But I guess there might be a version of apophaticism where you get a more radical, let's say, notion of ineffability, where the idea of precisification, the range of precisification is not even clear, right? And I think about this, the model would probably remains, too limited. Does that answer your question? I hope so. Okay, excellent, thanks.
Okay, so I have a question. It's about the stuff at the end of the talk on epistemicism. And I think I just got a little bit confused about how the model was meant to give a kind of argument in favor of the semantic theory. As I was thinking about it, it felt like a epistemicist could take the semantics you were giving and just not have Y be a kind of free parameter, but just have it be a kind of fixed by the kind of use facts in the community, but unknown by the speaker and unknown by the listener. And I was thinking you could have, the listener have a probability distribution over the various possible values of Y, even though it's fixed, it's just sort of unknowable because of these, the contingency of these semantic facts. And I was not seeing how that would, it looked to me like the model would work the same way if I interpreted it that way.
Yes, I think that's a very good objection. I think you're right. You're right, actually. I haven't considered that objection, but I think you're right. It's one way in which we could interpret the model. Of course, I'm tempted to think that if things happen the way described, it would be less parsimonious. Let's say it would seem to be more costly to have to imagine first a known value, let's say a fixed value in the meaning of around. Remember that there are determinate values for numbers of people at the party. Whether there are determinate values for what around means in the first place. Remember this Y parameter, right? We have, as you said, right, we have the X value. That is a matter of uncertainty. The Y value is a matter of uncertainty, but is it uncertainty about something we really think could be a fixed value? It is possible. I view it, obviously you're right that I haven't given an argument to forestall your objection. I'm now trying to come up with one, which would be in terms of parsimony, suggesting that the notion of flexibility is actually goes hand in hand with the existence of this parameter in the truth conditions of the expression. Because of course, that's not really a very articulated argument. So each time, though, I've tried, it's not the first time I'm sort of a battle with epistemicism. I think that was already long ago in my PhD on different aspects, other aspects of epistemicism. But I find it always of course, it's very hard to give a knockdown argument if there be, or of course in philosophy, but because there's always a loophole, let's say, and what you're suggesting is something like that. Now, still, I think I want to take the objection seriously because some people have said that maybe for around, for instance, we may have conventions. For instance, my colleague Benjamin was noticing that around does not seem to give obvious faultless disagreement in the way in which some other, let's say, vague predicates give rise to faultless disagreement. Yeah. So, yeah, I grant your objection, and I think the answer I would give is that it would be strange if, let's say, around was meant to track in its meaning, at the meaning level, right, a precise between interval which is unknown. We can probably come up to sort of agree on a range of interpretations which are more likely, or we can conventionalize as we do for other vague expressions. But that's, to me, is not really sufficient, right, to argue for epistemicism. But feel free to sort of push back. I'm not giving a good answer.
That's fine. I think we have another question from Nevin, and then the queue is empty after that. So if anybody has any other questions they want to ask, just send me a message.
Yeah, so I was just wondering, this was very brief at the end, but I think you said at the very end that your model implies that it's not the case that for every vague expression, there's a precise one that's more informative, if informativeness aims at communicating the relative probability of worlds. And I wondered, well, what if we just had a really complicated expression that says, here's my probability for all of these different numbers of the possible numbers for people at the party? Wouldn't that be more informative in communicating the relative probability of different numbers?
So you're thinking of an expression which would sort of freeze the meaning, which would abbreviate the meaning of a more complex, precise expression in this case?
Well, I wasn't even thinking abbreviated. I was just thinking that I go on for 5 minutes telling you, I think there's an 80%, there's a 50% chance that there are 70 people at the party. There's a 10% chance that, and so on. I just go on like this until I go through all the possible numbers. That's what I was thinking.
Yes. Okay. But let's suppose I coin a word for that meaning, right?
Okay.
The question is, so this is a precise meaning, right? Arguably, given the way you described it.
Yeah.
So, your example, it looks a bit like the example I gave initially, right? I'm 80% confident that blah, 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 right? That the number is between 60 and 80. There actually, the competition between that expression and around is not easily settled in the model without bringing in the notion of cost again. So that goes back also to Sam's question.
Yeah.
And to fully rationalize the use of around, we need, again, I think, to bring in this notion of cost for such expressions. In fact, we hint in the paper that the maxim of manner is also relevant in this particular case, but we just don't right away incorporate manner in terms of this notion of cost, but that's where it kicks in the approach. You're absolutely right.
Yeah, that seems very plausible to me as to what to say here, that to bring in costs.
Yeah, so it means ultimately it means that the three, at least the three maxims, quality, quantity, and sort of manner interact to sort of rationalize vagueness. But our proposal is, if you sort of set all the costs to be equal, and so leave costs implicit in the background, there's already, let's say, we see a function of vagueness which goes beyond, just securing quality, which is not, it's not entirely obvious. I want to stress, because when I started this project in 2017, I think I was initially naively thinking, only in terms of quality, and not seeing the dialectics sufficiently clearly between, this notion of being vague and being logically weak, and so there's also more work actually in the paper, sort of, again, Benjamin Spector established what I think is an impressive result, suggesting that, when you compare our model to a model called the lexical uncertainty model of Bergen and co-authors, you can show that in their approach, if we try to give an account of the use of vague expressions using their approach, basically only the support of the speaker's distribution matters, not the shape of the distribution, whereas our model actually is sensitive to support and to shape. And again, shape is this dimension for which you don't need to bring in notion of costs, but that you want to reflect in communication.
So the next question comes from Peter Fritz.
Yeah, thanks. Hi, Paul. Thanks for this talk. It's really super interesting. I have sort of maybe this is partly a follow-up to Dimitri's point and to your reply. I feel like maybe I haven't tracked every move back and forth here, but my thought was, I completely get your intuition that it would be kind of weird if about had some kind of a fixed, if the semantics of about involved some kind of a fixed parameter and the vagueness of about was explained purely in terms of our ignorance of that parameter. But presumably the epistemicist would here say that there is context sensitivity in about, and that the parameter varies from context to context, and it's our ignorance of the contextually determined parameter which accounts for the vagueness. And that seems less weird to me. I mean, still, of course, weird because epistemicism is always a little bit counterintuitive, but I don't feel any sort of additional counterintuitivity in this case when one's context sensitivity is taken into account.
Right. Yes, good, thanks. Yes, so you're right. What is the role of context in would there be a different way of, let's say, incorporating the context in this account of vague expressions? Here, what we say is basically the open parameter is really part and parcel of the truth conditions. Other option is to say, trying to tease apart that from, other option to say the truth conditions are fixed. We could imagine that, for instance, let's use the example of tall, maybe, right? So the analogies for tall, semantic view is to say, well, tall really means taller than X, where X is a threshold, which can vary. But you could imagine that tall means taller than, or being in the upper third of the population in any given population, let's say, right, in terms of size. And if you really are above that threshold, you're tall, and if you're below, you're not tall. But indeed, let's say, depending on what you're talking about, we may not have an idea of, let's say, the distribution of the heights of people in the population, or even, yeah, we may not be sure about what items we're talking about. So, and I think that would be the sort of picture that you're reporting here. So, and probably for a round we can give the same idea, right? You could maybe stick to the Zolt truth conditions, which in a way involve something fixed, and then play with the U parameter and to say, well, there is ignorance about the granularity, for instance. And that would be, I think, more similar to a sort of epistemicist picture. And again, I think it's a real challenge to tease apart between these two, these views. I know that some colleagues of mine, I mean, with very sophisticated accounts of vagueness, like Alexandre Kremers, for instance, has a view of the meaning of toll, which is something like what I just described and what you were hinting at. And that's so in a way that falls much closer to epistemicism. So how eventually to tease apart between them, I think maybe other elements of our view of language and grammar could help here. So the way in which, let's say, toll and toller relate to each other, or the way the positive and the comparative form relate to each other, is that easily accounted for if we have if we go only for this view that the context is something beside the truth conditions as opposed to within the truth conditions. Obviously, I'm leaning for one view, because I think the burden is on the sort of opponent to show that the alternative view is more plausible. But you're right. I grant to you as much as to Nevin, as to Dimitri, who was asking the question first, that I haven't really given a sort of refutation of an alternative epistemic account.
Yeah, I certainly wasn't thinking that this was an argument for epistemicism. Just like, yeah, adding to Dimitri's.
Yes, no, thanks.
Against their point against epistemicism.
No, that helps. That helps me articulate also what the alternative is between these two views of context, right? Because when I say what is semantic vagueness is the presence of a contextual parameter within the truth conditions, I usually don't view the epistemicist view of semantic vocabulary to be that. Yeah, and yeah, I hope I'm not misrepresenting epistemicism here on their view of the way context plays with truth conditions, but I don't think so.
Okay, I think we have time for one more question from Eunice Prasetya.
Hi, is my mic working properly?
It's working,
yes.
Yeah.
All right,
Thanks.
all right. Thank you for the talk. I have just one quick question. What would you say to something like the following case? So suppose someone asks me, what is the temperature at which helium becomes solid? And I say around 0 Kelvin. It seems that I've said something accurate, but it also seems I haven't implied that you should assign normal distribution that peaks at 0 Kelvin, because we know it's in fact not 0 Kelvin.
Yeah, thanks. That's good. That's good. So again, I think this case is very reminiscent of a situation in which you know the actual value to be different from the target number you're using after a round, but there's a benefit in using a round because you're selecting as a target number a round number, right? So I think this relates to Sam's question initially, right? Which was that in cases in which a round number is sufficiently salient and probably effective, cost-effective, you could use that expression consistently with a model. But of course, this, as you're definitely right, this, if you take the current version of the model I gave you, it doesn't straightforwardly account for the case you're describing. So only the extension of the model with costs inbuilt and a distinction between round and non-round numbers does the job.
Okay, wonderful. So everyone join me in thanking Paul for a fantastic talk.
Thanks so much for your excellent questions and for this discussion. It was very productive.